just 4 light-years away from us. There's a world orbiting the star next door, a planet that could change everything we think we know about life in the universe. It's called Proxima b, our closest exoplanet, a place that, by cosmic standards, is practically in our backyard. And yet, for all our technology, for all our telescopes scanning the skies, it remains a mystery shrouded in red starlight. Proxima b orbits Proxima Centauri, the faint red dwarf that burns quietly at the edge of our night sky, the closest star to our Sun. Around that dim ember of a star, this planet completes its orbit in just over 11 days. A world locked in eternal tension, one side bathed in constant daylight, the other frozen in endless night. And somewhere between them, in that thin line of twilight, may lie the key to one of humanity's oldest questions. Could this small, rocky world be an ocean planet, covered by vast seas that never see the dawn? Could there already be life there, beneath alien waves, under skies painted by a red sun, watching us from across the dark? Scientists have studied its faint signals for years. They've measured the subtle wobble of its star, traced the rhythm of its pull, and uncovered clues that suggest this world may not be barren at all. Some climate models even hint that Proxima b could host liquid water, maybe clouds, maybe storms, the building blocks of everything we understand as life. But if it truly is a world where oceans flow and winds blow under a foreign sun, how could anything survive there? Proxima Centauri is not a gentle star. It flares, erupts, and sends waves of radiation powerful enough to strip an atmosphere bare. Any life that exists there would have had to adapt, or hide, perhaps beneath the surface, perhaps beneath the sea. For now, it's all speculation. No telescope has seen its surface. No probe has sent back an image. And yet, the evidence keeps growing, whispering that this world, this tiny, invisible neighbor, might not be so different from our own. In the coming years, new eyes will turn toward it. Powerful telescopes capable of piercing the glow of its star, searching for the faintest glimmer of life, a reflection, a color, a chemical trace that says, we are not alone. Because Proxima b isn't just another planet. It's the closest possible mirror of our own existence, a reminder that the next Earth might be just beyond the cosmic fence that separates us from the stars. Just over 4 light-years from Earth, our nearest stellar neighbors quietly traverse the galaxy. At first glance, they seem ordinary, familiar, even. But look closer, and the story becomes extraordinary. This is the Alpha Centauri system, a triple-star family that glimmers like a jewel in the night sky. 2 of its members, Alpha Centauri A and B, form a tight binary, orbiting each other every 80 years or so. Alpha Centauri A shines with a warm, yellow light slightly brighter than our Sun. Its partner, Alpha Centauri B, glows soft orange, a little smaller and cooler, yet still a celestial companion of remarkable stability. Together, they resemble our Sun in many ways, but carry their own unique stories of mass, age, and energy. Then there's the third star, Proxima Centauri. Small, faint, and unassuming, it's the closest star to us in the galaxy. Just a fraction of the Sun's mass and radius, this red dwarf is a quiet powerhouse, capable of sudden, violent flares that ripple across space. Its surface burns at barely half the Sun's temperature, and yet, despite its diminutive size, it holds a secret that would astonish astronomers for decades to come. And yet, orbiting this tiny star, something remarkable was discovered, a planet that challenged our expectations. In 2016, astronomers noticed a subtle, almost imperceptible wobble in Proxima Centauri. A star that should have remained steady was moving, tugged ever so slightly, as if by an invisible hand. This is the essence of the radial velocity method, where planets reveal themselves not by light, but by the gravitational whispers they imprint on their stars. Through meticulous observations with spectrographs of unprecedented precision, a new world emerged from the data, Proxima b. About 1.17 times the mass of Earth, rocky and dense, it circles its star in just over 11 days. Its proximity to Proxima Centauri is astonishing, closer than Mercury is to our Sun, yet, because the star itself is so faint, this world isn't scorched. In fact, it sits comfortably in the star's habitable zone, where liquid water could exist. A world that should have been dead may, in fact, have conditions that could support life. But what makes this tiny planet so unique is not just where it is, but what it could hold. Oceans, clouds, or even the faintest trace of life, tucked beneath alien skies, waiting for us to discover it. Proxima b is a world of extremes. Locked in a gravitational embrace with its star, it is tidally locked. One side bathed in eternal daylight, the other plunged into endless night. Across that stark divide, temperatures swing dramatically, yet along the thin line where day meets night, a delicate balance may exist. Climate models from the University of Exeter and the UK Met Office suggest that these twilight zones could be surprisingly stable. Winds might circulate heat, clouds could form, and perhaps, just perhaps, oceans of liquid water could linger along this boundary. In these narrow bands, the faint possibility of photosynthesis emerges, where alien plants, or some other form of life, might capture the weak light of a distant red sun. Yet the environment is not gentle. Proxima Centauri is an active star, prone to violent flares that could strip the planet of its atmosphere in moments, blasting the surface with radiation far beyond anything Earth has experienced. And still, life has a way. On early Earth, organisms thrived under ultraviolet bombardment. Coral polyps today survive by producing fluorescent proteins that neutralize intense sunlight. Could life, if it exists on Proxima b, have adapted in similar ways, hiding beneath oceans, burrowing into rocks, or producing light to cope with harsh conditions? If life really exists there, how could we ever prove it? Imagine the world at night, along that narrow twilight band, oceans shimmering with bioluminescent light, pink and violet against the darkness of space. We can speculate on the types of patterns life might create if it existed there, responding to the faint energy of Proxima Centauri. One day, the next generation of telescopes could detect these faint signatures, subtle reflections of color, chemical traces in the atmosphere, or, hypothetically, signs that life might exist. From across 4 light-years, a flicker of light could tell us that this distant world is not barren. Proxima b is a planet of contrasts, half frozen, half burning, yet somehow alive with motion and light. A world breathing quietly in the darkness, waiting for humanity's gaze. But before we can see it, before we can confirm the life that might exist there, we must first find a way to reach it. Traveling to Proxima Centauri with today's technology is a journey beyond imagination. If we were to launch a conventional spacecraft, it would take 165,000 years to reach the star system, a voyage spanning more than a millennium of generations. The vast emptiness of space seems insurmountable. Yet human curiosity refuses to be confined by time. Enter the Breakthrough Starshot project, a visionary plan that could bring the stars within our reach. Instead of massive rockets, scientists propose sending thousands of tiny probes, each weighing less than a single gram. These microprobes would unfurl ultra-thin solar sails, and an array of powerful lasers from Earth would accelerate them to 20% the speed of light. In mere decades, these flecks of technology could cross the gulf of interstellar space, reaching Proxima in just about 25 years. Every probe would race independently, streaming data back to Earth, revealing the secrets of a world no telescope can yet fully capture. Imagine the moment. Within our lifetime, we might see another Earth. We might glimpse oceans, mountains, or the faint shimmer of life on a distant planet, all from a vessel no larger than a sheet of paper. And yet, Proxima b is only the beginning. This star system does not hold just one world, it hides more than we ever imagined, a family of planets each with its own story, each with its own mysteries waiting to be uncovered. Proxima b is only the first chapter of a much larger story. Orbiting the red dwarf are other worlds, each more mysterious than the last. Farther out lies Proxima C, a massive planet that could be a super-Earth or a mini-Neptune. Its exact nature remains uncertain, but astronomers suspect it is surrounded by colossal rings of dust and rocky debris, perhaps 5 times larger than Saturn's. Frozen and distant, it takes over 5 Earth years to complete a single orbit, a world where temperatures plunge to extremes beyond imagination. Closer in, almost hugging the star, is Proxima D, tiny, dense, and fast. Orbiting every 5 days, it is likely a rocky, volcanic planet, heated by both its proximity to Proxima Centauri and internal forces. Its surface is too harsh for life as we know it, yet it tells a story of planetary formation and resilience under conditions that challenge our understanding of what a planet can endure. 3 worlds, 1 star system, each rewriting what we thought we knew about planets. A system once thought simple now reveals layers of complexity, diversity, and untold potential. And as new telescopes awaken, bringing sharper eyes and deeper insight, the answers we seek may already be on their way, ready to illuminate these distant neighbors and perhaps uncover secrets that will reshape our understanding of the universe. The search for life beyond our world is no longer a dream, it is a carefully measured pursuit, powered by the most advanced technology humanity has ever built. Telescopes like the James Webb Space Telescope are sending back unprecedented images, revealing the atmospheres of distant worlds. The TOLIMAN telescope aims to detect subtle wobbles in nearby stars, hinting at planets yet unseen. And the European Extremely Large Telescope, with its staggering 39-meter mirror, promises to pierce deeper into space than any eye before it. Every new image, every faint signal we capture, brings us closer to answering one of humanity's oldest questions. Are we truly alone? Each discovery connects us to the cosmos, reminding us that our quest is both scientific and profoundly human. We peer into the darkness, not just to chart the stars, but to understand our place among them, to trace the faint outlines of life where we least expect it. And yet, even if Proxima B remains silent, if it offers no signs of oceans, clouds, or life, that very silence carries meaning. It is a message from across the void, a cosmic reminder of the vastness of the universe, and of the precious, fragile life we call our own. Just 4 light-years away, a whisper of another world stirs, a planet orbiting a faint red star, so close by cosmic standards, yet cloaked in secrets we have only begun to uncover. Proxima B is more than a point of light in the sky. It is a mirror, reflecting the possibilities of life, resilience, and the unknown that lies beyond our own planet. If another Earth exists so close, how many more worlds, hidden in the darkness, are waiting for discovery? How many suns shine on seas, mountains, or life forms we cannot yet imagine? Each unanswered question is a call to wonder, a reminder that the universe is vast, and our curiosity is boundless. Maybe they have been patient, waiting for us to look up, to listen, and to reach across the gulf of space. In that waiting, there is promise, the promise that the search for life is not just about others, but about understanding ourselves, our fragility, and our extraordinary place in the cosmos. All speculative discussion is based on current scientific models. No direct evidence of life has been found on Proxima B. All insights are grounded in science, exploring our nearest stellar neighbors and the possibility of life beyond Earth. If this journey sparked your imagination, like the video, subscribe for more explorations of the universe, and share your thoughts in the comments. What do you think life on Proxima B could look like? Could we ever truly detect it from Earth? Your ideas are part of the conversation that pushes humanity further into the stars.